I want to show you two, okay? And what I'll do, I'll show you these two. You'll have a shortened assignment tonight. So what I want you to do whenever we finish this is to finish the homework from last night in your group. Turn that in, and then the homework from tonight. So if you finished everything from last night, you'll be able to do tonight's in here and won't have to worry about it. All right, so there's two special patterns I want to talk to you about. The first one is difference of two squares. And I hope that last night you recognized the pattern, or it started to make a little sense to you. You started to notice what was going on with the problems, but difference of two squares is exactly what it says it is. Difference means what in math? Subtraction. And a square is what? The power of 2, or times itself twice, right? So difference of two squares literally means I have two terms that are both perfect squares, and there is a minus sign in the middle. Now, when we factored this yesterday, we put a 0x in the middle, and then we grouped it, slashed it, and did it right. But if you recognize that they're both, this does not work if it's a sum of two squares, only a difference of two squares. If you recognize them both being perfect squares, then you can factor it as the square root of the first minus the square root of the second times, do the same thing but make one a plus. And if you multiply that back out, you will come back out to x squared minus 36.
I did that last night.
Did you? Did you figure the pattern out?
Yeah.
Okay. Even for more complicated difference of two squares, if it was 81x squared minus x minus 6, x plus 6. 1 minus 1 plus. If I had to multiply those two things together and find what multiplied to that but added to 0, I'd be here all day, right? But if you recognize that they're both perfect squares, right? What's the square root of 81x squared? How about 225?
15.
It's factored. Easy? Just remember, if that was 81x squared plus 225, it would not work. Okay. Only when it's a difference. Say again?
Is there like a special pattern for the plus?
No. And actually, if this was 81x squared plus 225, it would be a cannot be factored. There are no two terms that multiply and add right. All right, are we good on difference of two squares? That's the easy one. The second one, the difference of two squares we will use over and over and over and over and over again. The next one we will use a lot, but especially when we get to, I think it's 1/7 or 1/8 when we're completing the square. It's called a perfect square trinomial. All right, so this one has to meet 3 criteria, okay? First of all, it's a trinomial, so it has 3 pieces, right?
Yeah.
The first criteria is that the second sign must be minus. Must be plus. God, Stacy, come on. That's criteria number 1. Okay. Criteria number 2. I actually shouldn't have given it to you this way. I'm going to make this a c squared and a squared. Just add a little squared above those. The second criteria is that these ends must be perfect squares. So this and this have to be a perfect square. Now here's the kicker. This is the part where you really have to look. The middle, the very middle term has to be the square root of the first times the square root of the last doubled. Okay? And I'm just using this one, and I know that this sounds really confusing right now. It is. Okay? But if all this rings true, then what happens is it factors as the square root of the first sign, the square root of the last squared. Let me get perfect square. Let me give it to you with some numbers instead of all the variables, and I think it'll make more sense. Miss Wilson always says it has to square dance. Plus, let's do 25, 2, and 20. So you're asked to factor this, okay? And I hope that the first thing you see is you notice that the ends are perfect squares here. Do you see that? Yes. Okay. So then I want to look, and I also go, wait, now that second sign is also a plus. That's good. I'm right on the track for a perfect square trinomial. This is a perfect square. This is a perfect square. This is plus. So now I want to know, does it square dance? In other words, if I take the square of the first, the square of the last, multiply and double. Square, square, multiply and double. Does she not do this with y'all?
No, she never did this.
Okay. She'll get up and like dance around. You know how Miss Wilson is. Okay. Square, square, multiply and double. Well, what's the square root of 4x squared? 2x. What's the square root of the last?
5.
If you multiply those two things together, what do you get?
10.
Now double it. Is that what sits in the middle?
Yes.
It is a perfect square trinomial, which means to factor it, it's 2x minus 5 squared. It's just a pattern. It always works. We'll use it whenever we complete the square. Let me give you another one. You tell me perfect square trinomial or nah. Yes or no?
Yes.
No.
This one, the second sign has to be positive. The first can be positive or minus. This sign is the first sign.
Yes.
It's not happening. It's a no.
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 Why is it not?
Because it's double. It's 6
Does it square, square, multiply, and double? It just squares, square, and multiplies. It doesn't double. 4x times 6 is 24x. That if you double it. If I change it, however, to 16x squared plus 48x plus 36, now it works, and it would factor as square root of the first sign, square root of the last.
Oh, wow.
I think I threw you off. I threw myself off with those weird variables in the front. I don't know why I did, but I never do it like that.
I still don't understand how you got the thing for 2x minus 5 squared.
Square root of 4x squared is 2x. The first sign is minus, and the last, the square root of 25 is 5.
Okay.
So you don't do anything with the negative?
If you were to multiply these two back out, and the only thing you use at negative 24 is to check that it square dances. If you were to do, because that's what 2x minus 5 squared means. If you FOILed this out, you'd have 4x squared minus 10x minus 10x. Negative times a negative is a positive. Combine like terms, you come back to the same thing. It pops back out when you multiply it out. Other questions?
It's a different way.
Yes, it's a shortcut. Okay.